Hi, good morning. Welcome to my channel. Let's start Maths, grade 11, chapter 6, Permutations and Combinations. Subtopic is Combinations. Learning objectives. After this session, learners will be able to define the concept of combination, apply the concept of combination to solve problems. Combinations. Let us now assume that there is a group of 3 lawn tennis players XYZ. A team consisting of 2 players is to be formed. In how many ways can we do so? Is the team of X and Y different from team of Y and X? No, here order is not important. In fact, there are only 3 possible ways in which the team could be constructed. That is XY, YZ, ZX. Here, each selection is called a combination of 3 different objects taken 2 at a time. In a combination, the order is not important. Therefore, 3p2 is equals to 3c2 into 2 factorial. That is 3 factorial divided by 3 minus 2 factorial is equals to 3c2 into 2 factorial. That is 3c2 is equals to 3 factorial divided by 2 factorial into 3 minus 2 factorial. So, in general way, NCR is equals to n factorial divided by r factorial into n minus r factorial. NPR is equals to NCR into r factorial. If NC8 is equals to NC2, find NC2. Given,
how do you solve this problem?
Oh, we'll see here the comparison we need to do. As it's given, NC8 is equals to NC2. Now we know the formula NCR is equals to n factorial divided by r factorial into n minus r factorial, right? Here we'll, instead of the r, we'll keep it as a 8. In this second case, we'll keep r as a 2. Now n factorial divided by 8 factorial into n minus 8 factorial is equals to n factorial divided by 2 factorial into n minus 2 factorial. Can we cancel this n factorial and factorial?
Oh yeah.
Then we can write 8 factorial into n minus 8 factorial is equals to 2 factorial into n minus 2 factorial. Now we'll equate n minus 8 is equals to 2 or either n minus 2 will be 8. Whatever the way we solve, we are going to get n as a 10. So therefore n is equals to 10. Let us substitute. We need NC2, right? So in place of n, let us substitute 10 here. So 10 factorial divided by 2 factorial into 8 factorial. That is 10 into 9 into 8 factorial. 8 factorial we can cancel. That is 10 divided by 2 factorial. 10 into 9 divided by 2 factorial. That is 45. Plus 2 ones are 2 5s are 5 9s are 45, right? Therefore, NC2 is equals to 45.
Oh, now I see.
Determine n if 2nc3 is to nc3 is equals to 12 is to 1. Our second one is 2nc3 is to nc3 is equals to 11 is to 1. Solution. 2nc3 is to nc3 is equals to 12 is to 1. We know the formula NCR is equals to n factorial divided by r factorial into n minus r factorial. So let us substitute here this one. 2n factorial divided by 3 factorial into 2n minus 3 factorial is to n factorial divided by 3 factorial into n minus 3 factorial is equals to 12 is to 1. Now here 2n factorial we can write it as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial. We are halting here because the denominator is 2n minus 3 factorial. We can cancel 2n minus 3 factorial, 2n minus 3. Similarly here also we can write n factorial as n into n minus 1 into n minus 2 into n minus 3 factorial. We'll stop here because the denominator n minus 3 factorial is there, can cancel here. So we'll cancel n minus 3 factorial, n minus 3 and 3. Then we are going to get as 2n into 2n minus 1 into 2 into n minus 1 divided by n into n minus 1 into n minus 2 is equals to 12. After cancelling here n minus 1 and n, we are going to get as 2 into 2 into 2n minus 1 divided by n minus 2 is equals to 12 divided by 1. By cross multiplying, we are going to get 8n minus 4 is equals to 12n minus 24. By transposing variables to one side and constant to one side, we will get as 12n minus 8n is equals to 24 minus 4. It is 12n minus 8n, that is 4n. 24 minus 4 is 20. Let us transpose 4 to the other side. Then we will get as n as a 20 divided by 4. That is n is equals to 5. Let us solve subsection 2. 2n C3 is to NC3 is equals to 11 is to 1. Let us apply this formula here and compare. Then we are going to get as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial divided by 3 factorial into 2n minus 3 factorial is to n into n minus 1 into n minus 2 into n minus 3 factorial divided by 3 factorial into n minus 3 factorial is equals to 11 is to 1. We will cancel here n minus 3 and 2n minus 3 here. Then we are going to get 2n into 2n minus 1 into 2 into n minus 1 divided by n into n minus 1 into n minus 2 is equal to 11 divided by 1. That is 2 into 2 into 2n minus 1 divided by n minus 2 is equal to 11 divided by 1. That is 4n minus 8n minus 4 is equal to 11n minus 22. Transposing variables to one side and constant to one side will get 11n minus 8n is equal to 22 minus 4. That is 3n is equal to 18. That is n is equal to 18 by 3, that is 6. Therefore n is equal to 6. Shall we solve problem number 3?
How many chords can be drawn through 21 points on a circle?
To draw a circle, how many points do we need? 2 points, right? So here is a circle. We are drawing a chord. So 2 points are enough. So here, as per this, as there are the 21 points, we consider this 21 points as a n and r as a 2, because to draw a chord on a circle we need only 2 points. Now let us use the formula. NCR is equal to n factorial divided by r factorial into n minus r factorial. That is, instead of n, let us substitute 21. In place of r, let us substitute 2. So 21 factorial divided by 2 factorial into 21 minus 2 factorial. That is 21 factorial divided by 2 factorial. 21 into 20 into 19 factorial divided by 2 factorial into 19 factorial. We can cancel 19 factorial here. 2 ones are 2 tens here. Then we are going to get as 21 into 10, that is 210. Number of chords possible to draw through a 21 points on a circle is equal to 210.
In how many ways can a team of 3 boys and 3 girls can be selected from 5 boys and 4 girls?
So in a team there should be 3 boys and 3 girls, but total there are 5 boys and 4 girls are there. Now let us assume here n1 as a 5 and this girls n2 as a 4, and the boys to be selected as r1 as a 3 and the girls to be selected r2 as a 3. Then we will use NCERT formula n factorial divided by r factorial into n minus 1. This will apply separately for boys and girls also. n1 will consider this boys, so 5c3 into 4c3. Therefore, that is 5 factorial divided by 3 factorial into 5 minus 3 factorial into 4 factorial divided by 3 factorial into 4 minus 3 factorial. That is 5 factorial divided by 3 factorial into 2 factorial into 4 factorial divided by 3 factorial into 1 factorial. It is 10 into 4, 40. Therefore, number of ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls is equals to 40.
Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color.
Yes, here each we need 3 colors. So from the 6 red balls we need 3 red balls. From the 5 white balls we need 3 red balls and 5 blue balls 3. So we have there is 6 red balls, 5 white balls, 5 blue balls. Therefore 3 balls of each color to be selected. That is 3 red balls, 3 white balls and 3 blue balls. We know that NCR is equal to n factorial divided by r factorial into n minus r factorial. From these 6 red balls, we select 3 red balls. From these 5 white balls, we select 3 white balls. These 5 blue balls, we select 3 blue balls. That is 6c3 into 5c3 into 5c3. That is 6 factorial divided by 3 factorial into 6 minus 3 factorial into 5 factorial divided by 3 factorial into 5 minus 3 factorial into 5 factorial into 3 factorial divided 5 minus 3 factorial. Upon cancelling and all, we will get as 6 into 5 into 4 divided by 3 into 2 into 1. 5 into 4 divided by 2 into 1. 5 into 4 divided by 2 into 1. Upon multiplying that one, we are going to get as 20 into 10 into 10. That is 2000. Very good. So, number of ways to select 3 balls of each color from 6 red balls, 5 white balls and 5 blue balls is equal to 2000 ways. Determine the number of 5 card combination out of a deck of 52 cards if there is exactly one ace in each combination. Solution. In a deck of 52 cards, there are 4 aces and 48 other cards. So 5 cards to be selected. That is, 1 is A, 1 should be ace and 4 should be other. Therefore, here in this 4 cards, we have to select 1 card, and the remaining 48 cards, we have to select 4 cards. So here we'll use the NCERT formula, n factorial divided by r factorial into n minus r factorial. From these 4 A's, we'll select 1 A's, therefore 4C1 into this 48 other cards apart from non-A's cards, we'll use it 48C4. That is 4 factorial divided by 1 factorial into 4 minus 1 factorial into 48 factorial divided by 4 factorial into 48 minus 4 factorial. That is 4 factorial divided by 3 factorial, 48 factorial by 4 factorial into 44 factorial. Upon simplification, we are going to get as 4 divided by 1 into 48 into 47 into 46 into 45 divided by 4 into 3 into 1. That is, upon multiplying 8 into 47 into 46 to 45, we are going to get 8 into 97,290, that is 7,78,320. So, number of 5 card combination from a deck of 52 cards with exactly 1 ace is 7,78,320 ways.
Oh! In how many ways can one select a cricket team of 11 players from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers?
Yes. So here there are 17 players are there, but in this there is exactly we need 4 bowlers we need, but there is a 5 players can bowl. Okay. So the 5 players who can bowl in each team must be the 4 bowlers. So among the 5 bowlers we need to select 4. This other people there will be, apart from the bowlers there will be 12 members, right? Because from the 17 if we subtract 5 we are going to get 12 others can do. So from these 12 members we need 11. So 11 minus 4 will be 7. So 7 members we need to select. So 11 members should be selected, that is 4 bowlers and the 7 others. Therefore, we will use the formula NCR is equal to n factorial divided by r factorial into n minus r factorial. That is, from the 5 bowlers, selecting the 4 bowlers is 5C4 into remaining 12 other members, we have to select the 7 members. So 12C7. That is 5 factorial divided by 4 factorial into 5 minus 4 factorial into 12 factorial divided by 7 factorial into 12 minus 7 factorial. That is 5 factorial divided by 4 factorial into 12 factorial divided by 7 factorial into 5 factorial. Upon this, we are going to get 12 into 11 into 10 into 9 into 8 divided by 4 into 3 into 2. That is 4 into 3 is 12. So we can cancel here. 2 1 set 2 5 7 can cancel. Then we are going to get as 3,960. So number of ways possible to select a cricket team is equals to 3,960.
A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected.
Solution. From a bag of 5 black and 6 red balls, 2 black and 3 red balls to be selected. Okay. So here the black balls we have total 5 and we need to select 2. Red balls we have 6 and we need to select 3. So from the 5 black and 6 we need to use 2 black and 3 red, that is 5C2 and 6C3. In this one this is N, here this is R. Okay. Therefore 5 factorial divided by 2 factorial into 5 minus 2 factorial into 6 factorial divided by 3 factorial into 6 minus 3 factorial. That is 5 factorial divided by 2 factorial into 3 factorial into 6 factorial divided by 3 factorial into 3 factorial. That is 5 into 4 divided by 2 into 1 into 6 into 5 into 4 divided by 3 into 2 into 1. That is 200. Therefore, number of ways to select 2 black and 3 red balls from 5 black and 6 red balls is equals to 200. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? Here, from this program of 5 courses, the 9 courses are available, but the 2 specific courses are compulsory for every student. Okay, as this compulsory courses are the count as a 2, and this courses to be selected we can't visit as it is a compulsory, so 2 is there. So as there is a 2 are count as compulsory, so remaining how many will be left out for us? 7, because 9 minus 2 is 7. So other courses count will be 7, and this courses we need to select total should be 5. Already 2 is compulsory, so remaining should be 3. Therefore Therefore, 3 courses we need to select from the 7 courses. That is 7C3 by using the formula NCR is equal to n factorial divided by r factorial into n minus r factorial. 7 factorial divided by 3 factorial into 7 minus 3 factorial. That is 7 factorial divided by 3 factorial into 4 factorial. That is equals to 7 into 6 into 5 divided by 3 into 2 into 1. That is 7 5 is 35. Therefore, number of ways to select 5 courses if 9 courses are available and 2 courses are specific, that is equals to 35. Thank you.
Come again to our channel.